Hello everyone, and welcome to Learning Math with Mickey. Today we're going to be discussing how to do Euler's method approximation in Excel. So we have an exercise saying that we have a first order differential equation y prime equal to 2 times x times y. We're given our initial condition to be y at x equals 1 to be equal to 1. We also have our step h to be 0.1. And our question is, try to approximate the value of y at x to be equal 1.5. So let's fill out. We have x to be equal to 1 and y to be equal to 1. We have h, our step, to be equal to 0.1. We know that our next h must be equal 0.1 as well, because that's our step for x. Our next x is our previous x plus our step h, which makes sense to be 1.1. But how do we find our next value of y? In this formula to the right here, it is given that how do we find the next value of y? We take the previous value of y and we add to it our little step h, 0.1, times the slope of that function at that point. So what do? We take our previous value of y plus our step h times our function of the slope, which is given to be 2 times x times y. Times y. Great. What we do now, we use the Excel's most amazing feature, is that we take this all and we drag it down to the value of 1.5 for x to be 1.5. And we're given the value here to be 2.9278. Amazing, that's an approximation that we were looking for. But how do we know if it's close or far from our actual true solution? Using my differential equation skills, I have found out that the solution to this differential equation with this initial condition is y to be equal to the e to the power of x squared minus 1. Let's find the values. So we take exp to the power of x squared minus 1. We know that 1 and 1 equal to each other. Great. We drag it down and we receive a couple of values. We see that the first step, the approximating value of y and the actual y are somewhat looking alright. Then when we move forward, we can see that there's already a lot of deviation happening. So what I want to do, I want to graph it. But I don't want to graph this much, I want to graph a little more. Let's get to 2.3. And at x equals 2.3, you can already see that the approximating value of y and actual value of y are not looking the same. There's the actual value of y is double of what the approximation is. So let's graph it. Graph this compared to the actual values of y. I want to insert, I want to recommend a chart, and I can already see that they're deviating a lot. Already at the value of 2.3, merely 1.3 value from our initial condition, we can see that the error here is already 32 points, which is not as good if you would ask me. So from this, you can already tell that Euler's method is not the best method to use to approximate the true solutions of first order differential equations. But on the contrary, it was the very first method to be developed in order to approximate the solutions to a first order differential equation, which is amazing. It set up the first step for the humanity and mathematicians to start approximating and creating better approximation methods for the future, for even more variety of differential equations to come, which you'll see in the future. Thank you everyone for watching. That'll be it for today.